Welcome to another session of GOTO Unscripted. We're here in the beautiful Copenhagen. I live in London, and people in Denmark say it is often rainy and it is often grey, but the weather is absolutely beautiful. But that is of no concern, sort of, except for our enjoyment of the conference. But today I am joined by the one and only Dan at Terhorst-North. Dan, how's your conference going?
It's amazing. I've been to a lot of GOTOs. I was thinking about this. GOTO Copenhagen 2024 is 20 years.
Wow.
My first GOTO wasn't actually GOTO, it was called Yao back then. In fact,
very nice.
So I have several souvenir shirts. I've actually brought 6 shirts to this conference. I'm switching as I go through. 20 years ago, first joint talk with Martin Fowler. And at the end of the day in 2004, we were on a panel together. And at the end of today in 2024, we're on a panel together. So I feel like there's this wonderful kind of circularity to the whole thing, yeah.
So has anything changed in 20 years?
No. Yes, but it is interesting. I think, because, and again, I'm going to speak a little bit about GOTO and I think maybe a bit more broader. The GOTO kind of the Yao and the GOTO series of conferences have always been where I learn stuff. And where I learned stuff from the horse's mouth. So I first came across Clojure from like Rich Hickey and Stu Halloway talking about it at GOTO. HTML5, when that came out, the folks who are actually building it were here, and so on, right? And this morning, Sophie, who invented the AMD chip layout, is standing on the stage talking about the history of these chips. It's just bonkers. 20 years, I think the biggest shift is, if you look at how software delivery works, I think there was 20 years ago, this agile movement thing was very new, was very nascent. The world it was in was very structured, was very gated. It was really weird, right? It was not what the rest of the kids were doing. And it was seen as very maverick and irresponsible and all that kind of stuff. And in fact, the panel I mentioned, I remember there was a chap on there from the US Department of Defense, and he was busy telling us how we should run projects, and Martin and I were sitting on this panel going, no. I'm afraid we're going to find no middle ground at this point. And you play it forward, and certainly in most of the organizations I see now, it is really unusual not to have cross-functional software teams. People working together, solving a thing. They're not kind of, take this data and convert it and shove it into that thing over there. It's build this feature that's going to have this capability, and if there's some database stuff, do the database stuff. If there's some UI stuff, do the UI stuff. The fullish stack, it's not real full stack, but the fullish stack is normal, and that's exciting, right? And you see a lot on the socials these days about, agile is dead and agile is well. I look at it as like it's just become so normalized that it's not that interesting a conversation anymore in a good way, right? Why would you keep talking about the fact that we have clean running water when we've had clean running water for decades? But the clean running water people, aren't they like a stuck record? When they started, we didn't have clean running water. But guess what?
Yeah. I think that's entirely applicable, and that sort of keeps happening in a way. As you say, it's a good thing, when something becomes that ubiquitous and that useful and that everyone cottons onto it. And of course, not to denigrate marketing in any way, but when something becomes successful and good, it also becomes a marketing term, and everyone wants to be agile. Everyone wants to be in air quotes something else. And so it seems that agile then becomes everywhere, and then people use agile in the wrong way, and then that's sort of agile's fault rather than the implementation of agile. But in 20 years, nobody would think about deploying software in a non-agile manner. But I still think there's still a lot to be done. I think even CI/CD pipelines are sort of backbone of being able to deliver software is I think sort of in early days, and people are sort of still trying to figure out and build new novel ways to actually deliver software, even though it's been sort of 20 years of the ethos and the manifesto. So 20 years. You also mentioned about seeing the sort of future unfold here at GOTO. Are there any talks or any things which sort of sparked your interest to go, there's the beginning of something interesting?
I think beginning's probably a bit generous, but certainly growth and prominence of something that's interesting is, and I'm here for this, right, is folks like Holly Cummins talking about I guess the economics of software from a sustainability perspective. How do you write green software? How do you write greener code? And it's not generally when the people have had these conversations in the past about kind of environmental impact and sustainability and blah, it's kind of worthy but dull. Yeah. You know, it's like, oh, come on, all this climate stuff. But then what she's doing, which is brilliant, and what a bunch of other folks are doing, is they're saying, no, there's a strong economic model, there's a strong economic argument that better architected software is cheaper to run, has less environmental impact. Architecting, understanding of the mechanical sympathy, understanding the machines you're running on, understanding the impact your code has when it runs, it turns out, is as much about economics and as much about performance as it is about then running leaner. And I love that a conference with this kind of profile is running a talk like that and pushing a message like that, because it's absolutely a thing whose time has come. So that's really exciting.
And I think a lot of software has always been about efficiency, but that efficiency has often been about, because it needs to run in a constrained environment. Now with even cloud and sort of unlimited scale, sometimes that message is lost, that it's not that interesting. And I think her example was looking at Java and looking at the ways you can use GraalVM and Micronaut and things like that to make your Java program far more efficient, so that is saving less money. And electricity prices have shot through the roof recently. Right. I mean, there are colo providers who literally have gone bankrupt, and companies have been evicted out of colo facilities literally because their electricity bill has gone up. And if you can be more efficient with your code, you're using less server resources, you're using less electricity. 100% think that's super important. I mean, I happen to work for AWS and I happen to work for, in the serverless product team. And I mean, we build by the millisecond. And, if you are paying by the millisecond to write something, writing efficient code, which is efficient architectures, literally saves you money, and is also good architectural practices.
Well, actually, the serverless thing is interesting. There's a chap that you and I both know, GOTO Unscripted.
Yep.
He has a mind mapping web tool called MindMap. Again, I love he builds products to scratch his own itches, right? He wanted a mind mapping tool that he could use at a client site, and he wasn't allowed to install anything, so he shoved it on a website. And the back end of that is all AWS serverless. It's all Lambdas. And he said he was the primary user of all of the Lambda stuff, because basically all of the mind mapping is just in the browser. It's all JavaScript in the browser. The serverless stuff was if you want to get the mind map out. So if you want to render like PNGs or PDFs, and the entire user base of people who wanted PNGs and PDFs was GOTO. so it's like, well, I'm going to write the thing I want. And then this thing went viral. It turns out it's really popular in US schools. School teachers love it because there's some, I don't remember exactly the story, but it's some particular style of teaching in the US where mind map really lends itself. Okay. And there's certain templates that teachers started building, and he's got his lizard optimization thing now, where you look at like odd behavior, and rather than going, that's odd behavior, go, well, that odd, I'm going to make that odd behavior easier, and suddenly everyone's doing the odd behavior. So he did this thing, he built these templates for schools, and suddenly all these schools are using it. What does that mean? That means he now goes from like a few dozen people using MindMap to millions of people using MindMap, and they're starting to hit his serverless, his Lambdas. And he says the same story. Like he looked at the architecture, like the call kind of path of each thing, and he said that his big insight, his big epiphany, he said people think of Lambdas, of serverless, as stateless. He says it's not stateless; it's shared nothing, which is very different. So it can have state, right? It's just not allowed to talk to any of the other things, or not allowed to assume anything else is there. So you can, for instance, if you're rendering PNGs or PDFs, there's probably a bunch of stuff, static stuff that is useful to have already. So you make that all part of your serverless startup. Yep. Then you can service these things as quickly as you like, and then you have your wind down. So he architected very deliberately like this, and his bill went down to double digits of dollars a month, right? With millions of users, like insanely tiny bills. Yeah. Because the first few million hits or whatever are free, and then after that is 0.00 tiny per whatever. Yeah. And and it was the So there's a strong architectural, a strong economic drive to clean up your architecture. And that got me thinking, the last time this probably happened was the 1960s. Right, on the mainframe, when you were billed per CPU second, right, and so you wanted to write efficient code, because otherwise it was going to cost your company a ton of money, to IBM or to Amdahl or whoever's selling you your mainframes. And then we've had this middle bloated sort of 3 or 4 decades, where, Sophie this morning, she was saying like the compute is so far ahead of what you can do with programming languages. You idiots with your sequential programming languages throwing away your gigaflops or whatever. If you started writing much more parallelizable things, we've already got. Well, we're waiting for you, and that world starts to happen. So
I suppose that is the future of seeing what microprocessors can do. Never mind AI chips and all that kind of thing, which is going to be a whole new sort of paradigm. We're talking a lot about people. You're obviously well famous for behavior-driven design. That's been around for many years, and is very much also about the people and communication and the sort of 3 different stages of that. I know you said before that behavior-driven design was sort of based on test-driven development. How have the sort of 2 evolved? And we've got obviously Kent Beck talking at the conference here today, and he had this interesting concept he was talking about, which I loved, about test commit and release. So how if test commit
and rollback. Test commit and revert. Yeah,
got the wrong.
If it doesn't pass, you just lose your work.
Yeah, exactly. Yeah. So how does, if behavior-driven development was built on test-driven development, and this is a new way of thinking of the test size, the test part of it, how does the BDD evolve or move and change in a modern time? How should people think about it?
So I have to say, I just spoke to Kent recently. Obviously, he's at the conference. We just caught up, and I was saying that one of the things I've always found as a challenge introducing TDD to people is the kind of the ego-driven developer who said, I'm not going to write tests, so I stopped calling them tests. And he leant across and very generously said, you need to get over that. So on the very principled point that I refuse to get over it. They are, when you stand back and squint, when you're doing them both as intended, they're basically the same thing. I've always maintained they're the same thing. So it's not TDD's the down in the detail and BDD's the feature level. They're both. And they've always both been both. I started JBehave back in 2004, 20 years ago. In fact, 2003, Christmas Eve, in Cape Town, I registered the domain jbehave.org, much to my wife's dismay. She's like, what are you doing online on Christmas Eve? I've got to register this domain while it's in my head.
How many domains do you actually own?
Now.
Separate question, I'm going to derail you.
So I think of my domain renewal emails, right? It's God's way of telling me how bad a completer I am.
I agree, yeah.
Several.
I completely understand.
Actually, I have a platform right now. So this is an appeal. Okay, there's a number of projects that I have in flight at various stages of either not started or starting or whatever. It would be great to get some community stuff behind those. So one of them I thought of is howtotdd.in.
Okay.
Right. So I've got the domain howtotdd.in, and the idea is you go to howtotdd.in/Python. And it's just a one-pager, right? Oh. I know how to do TDD. I don't know Python. I know how to do TDD. I've never seen Rust, right? I've never seen whatever it is. There's a language, and typically, as an experienced TDDer, as an experienced, XPer or whatever, the first thing I want to do when I get a new language is write my first code. And the way I want to write my first code is I want to start with a code example, start with a test. Rust has, you have this thing called crates, and you have cargo, and cargo is this like Uber tool that brings everything together. And then in your Rust code, you put your tests in the same actual source file as your, the convention is you put it in the same code. I didn't know that. Right, with Go, it has a really cool built-in test framework called testing module, and the testing module allows, and when you see this, you can't unsee it. It allows you to fail a test, but that doesn't stop the test. Right, let me just let that settle for a minute. We are used to, so that all of the XUnit school of TDD frameworks start with SUnit and Smalltalk, and then it goes to JUnit, was the huge one, right? That's the one that caught everyone's attention. And then you get, C Sharp and all these other languages have it, but they're all based on the same thing, which is you make an assertion, if it fails, you raise an exception. That's it, game over. What Go does is they say, well, that seems strange. Also, Go doesn't really use exceptions like that, okay? So instead what Go does is when a test fails, you just go, yeah, test failed, and you just carry on, which means you can have a whole bunch of different things that you're checking for in the same test, and at the end of it, it goes, yeah, all these things were wrong. Yeah. It's more like an MOT for your car. You take your car in for a roadworthiness test, and don't go, oh, your front light's on, bye. And you go and fix your front light, come back, and I go, yeah, your brakes are... You could have told me that when I was... No, we're stopped at the lights. Yeah.
No, and I suppose that's efficient as well, because...
Right, they do the whole... They test the whole car, and they give you a list of things that need fixing. That's how Go does testing. And I was like, right, now I want to do that in all the languages. So it's not just the technology bit, it's the paradigm bit. Some of it's different. So anyway, howtotdd.in/languages, right? It's there, it's a repo. I've done nothing with it. Right, and so what I love is a bunch of pull requests of people going, I just did Rust, I just did Erlang, right? Because I don't know how to set up Erlang. Anyway, that's one. I have others.
Excellent, yeah. Yeah, that's sort of, it's funny, you sort of think of the tests of that and you think of the sort of procedural programming where it's a step by step by step by step, and when it fails, it errors out. And you think, no, you want to complete as much as you can and then understand, that part may have failed.
Give me a report sheet. Yeah. But it also has, if it knows it can't go further, it has fail now. So fail is register a fail and crack on. Right? Fail now is, we're trying to do some database testing, I can't even connect.
Can't complete,
I'm out. Yeah. Or, I tried to look, that row doesn't, that table doesn't exist. What was the next thing you wanted to check? I wanted to check these things over here. Yeah, they're fine. So your report is the test failed, and for these 3 reasons. And you're like, I want that in Java now. So we're at a thing called JGO testing. And JGO testing was more like JUnit 4 style. It was exactly that. It was a thing so you could use JUnit, but with Go style testing. So, and no one used it. Two people adopted JGO testing. Well, this is really helpful. And then, so I'm really good at starting open source projects. I'm not particularly good at growing them. Yeah.
I'm good at buying the domain names with great ideas and then not even getting to the following.
So I've got about a dozen of these that are rolling around each year and going, I still haven't done that.
Yeah. You also talk about things every programmer should know. And what are some of the things that every programmer should know? And what are the things that programmers shouldn't maybe know?
Right, so this is a wonderful, wonderful Kevlin Henney curated a series of books, 97 things.
I always wondered, why was it 97? Couldn't they roll it up to 100, or was there a...
I don't know. I don't know the origin of this. But I do know that Martin Luther nailed a scroll to a church door.
Yes.
Which was 95 things every cardinal should know.
Okay.
So it was like 95 criticisms against the church. So I don't know if
programmers are improving on.
I don't know if it's like, well, what's the first prime number above 90? Yeah. I don't know if it was that, or if it was, or if it was supposed to be 100 things, but they only got 97 volunteers.
Maybe it's more memorable. Yeah.
But I submitted one. Again, I'm not a finisher. I had about 4. I've probably got the other 3 in a file somewhere. And the one that I talked about was coding in the language of the domain. And it was really front of mind for me. I was working on trading. I do a lot of software in banks and trading systems, and I'd just been working on a trading system. And this is around the time Java's got generics, so there's angle brackets everywhere, but it's relatively new into Java. So if you're a Java programmer, they were really unfamiliar and really jarring, and you were still trying to get the hang of your brain parsing them and stuff. And somewhere amongst this code, there was a map of ints to a map of ints to ints, right? And there was a ton of logic around this. We were trying to figure out what this clearly important code did. And it turns out that the map of ints to ints was something like, and again, I'm going to get the language of it, but like a portfolio, which is basically a book of trades. And you have a portfolio has an ID, and then there's I think it was like a country code or something, or a region, which was also an ID. So these were 2 IDs, really. So it was like a country ID and a region ID, but they were just ints to ints. And the int in the outer map was a trader ID. Anyway, we've been mooching around in this code for literally days, trying to figure out what's going on. What's going on is certain traders are not allowed to see certain other books, right? They call it separation.
Yeah.
And there's a whole load of like legislation around it. It's like a hardcore regulatory. If as a trader you can see the other side of a book you're trading, right? That's illegal. That's like you can get massive fines for this. So it's a big deal. And this really critical business rule was locked up in this map of ints of maps of ints to ints, right? And so we kind of just refactored it, Kent style, small change at a time, change it, write the test, change the code, change the test, refactored it out. And we had portfolios by trader. And then we had trader was an object, and we had a trader had a method can see. And can see took a portfolio ID. So this whole map of ints to ints thing was just if trader.can-see portfolio ID, right, boom. Whole business rule, one line of code. Yeah. Right? So it was kind of where, if you bring the domain language into the code, it's not just that it makes it easier to see what's going on, it means that actual business rules jump out. So that was what I was trying to get
and it's fascinating
across.
because that obviously sort of brings together, even the other talks here have been about microservices and domain-driven design and all that kind of thing, connecting the business, much closer to the code.
Susanne Kaiser's lovely integrating domain-driven design, Wardley mapping, and team topologies, and it's just
and that brings it all together. And that's the exact
socio-economic study she's on. Yeah,
and that's an example that also a technical person, a coder, can understand the business intent from that far simpler because they can read it. It's even in English that it exactly.
So let me tell you the thing that sold is probably the wrong word, but the thing that sold domain-driven design to me, I'd come across the Blue Book and whatever we were doing stuff. I was working again in it might have been the same bank, but there was a new project and the team was very deliberately, very actively domain-driven, domain modeling and knowledge crunching and all that good Eric Evans stuff, and we were like really kind of focusing on that. And there was a moment, and I was sitting here, I remember this so vividly, I was sitting here, there was a pair of developers there, and they were talking about how you price an order. And it turns out the domain of pricing orders can get quite complicated, right? And they're talking about how you're going to price an order, and they're getting quite animated because there's some gnarly logic going on. Someone else walking behind the desk behind them leans in and says, "That's not how you price an order." Like, how do you price an order? And so this person's chatting away, explaining how to price an order. And while he's saying it, these two folks are sitting here, and these two folks were discussing the code, right? This trader was talking about how you price. None of them knew that the other one wasn't talking about the thing. Yeah. These folks thought that this person was talking about the code. They thought that these two folks would, and I just went, wow. Right, that's how it should be. Yeah. Right, you shouldn't know whether you're talking about the code when you're discussing how it works. I was like, right, I want that every day on my projects.
Yeah, that's
it was a thing of joy. Yeah.
Analogy, because ultimately all of IT and all of programming is about solving business problems. So when there is a language discrepancy or a difference in understanding between the two, things are just not going to work.
You're having to do translating in real time in your head, and it's just nuts.
Yeah. You worked at a time also at Thoughtworks, and there were some amazing luminaries. I'll include you in that as well.
Baby luminaries back then. Yeah.
Not at all. Who worked at Thoughtworks at the time and were, the unbelievable thought leaders of the time. In your idea, what caused that to happen? It was in London. Was it a random group of people who collected together? Was it the collaboration? Was it the time? Was it the city? Was it the beers in the pub? How did this sort of collection of genius all seem to happen?
You're very kind. I think one of the things, and obviously you look back on that time, there's a what's the word, a truism. If you ask any thought worker, any ex-thought worker, like what was the golden era of ThoughtWorks, it was them arriving plus a year to them leaving minus a year. That was the golden age. Everything else is rubbish, right? So for me, I can tell you that was the best time. No, it was.
So even to name names, because right. People who don't know who work at ThoughtWorks, that's sort of assuming.
So ThoughtWorks, global software consultancy. When I joined, my technical interview was a chap called Matt Femmel. I didn't know any of these people, by the way. I didn't know any of these people. There's a chap called Matt Femmel. Matt Femmel invented continuous integration. Or at least he wrote the first. He wrote cruise control. He wrote the first continuous integration server, right? That would probably have intimidated me if I'd known that. I'm quite glad I didn't know that. My first project manager was a lady called Rebecca Parsons, Dr. Rebecca Parsons, who's now like CTO Emerita from, like just insanely smart people. And it was...
Yeah, I'm Martin Fowler, James Lewis, Sam Newman.
So hang on, I haven't got there yet. Right,
even more.
So I was tech hire number 1 in London. So when I joined, there was an MD, there was a salesperson, there was an office manager, and there was me. There was a business analyst who kind of arrived and left shortly after. But so I was the first tech hire. And we grew that.
So you paved the way.
We grew that office. They had like a sort of an advanced party from Chicago. So we had so the idea of when you're a consultancy moving into a new territory, you land a couple of big gigs. This was a couple of big oil firms, energy firms, and so then you staff that from your pool of smart people. And you send over the best and the brightest because you want to make a good impression, and then you start hiring and backfilling is the idea, and then people can go home and some of them stay and whatever else. So I was the first local hire, and then we started hiring. So I hired Sam Newman, James Lewis. We hired Julian Simpson, the build doctor. I was working at a client, and he was their sysadmin. And I convinced Thoughtworks that we needed to hire ops people, and they were like, "Well, no, we don't really, because all of our developers kind of do sysadmin." I was like, no, that's true, but they do sysadmin like developers, right? A dedicated sysadmin is a different creature. And they said, well, no, we don't need, and eventually, so the hiring manager in the UK, the head of recruiting in the UK, was brilliant. And she and I cooked up this thing where we invented a job called an environments manager. And we basically wrote down Julian's profile and we put the ad out. He applied. And he arrived and he went out on his first project, and like the feedback after a day was, we need another 6 of these. Right, and so then Julian and I hired Chris Reed. Chris and I hired Jez Humble. Right? So you
More
had
continuous
like
delivery.
the great and the good of the build world then. But where does all this come from? Where this comes from is necessity. Necessity being the mother of invention. So we would be on client projects. They were typically very lean staffed. You didn't send loads of people in because clients don't want to pay for loads of people. And some of it was quite political or quite technically challenging or whatever. And for a lot of this stuff, certainly in the mid-2000s, you kind of had to invent your way out of it. And as we were inventing our way out of it, we started writing stuff down. So Chris and Jez and myself wrote the build production line, which was the first time anyone had written down, automated build pipelines and single deployable artifacts and promoting an artifact along a. And so, suddenly you're the build guy, right? But just, other people were doing it, we just wrote it down. And then the BDD I was trying to get client developers to do TDD, because for me it was like obvious and brilliant, and they were just going, we don't do tests, we're not going to write tests, we're programmers. What if I just don't mention tests? What if I try and teach TDD without using the word? That was this challenge I set myself. And I started talking about examples and blah and specification. They were like, of course you do that. That's fine. And suddenly they were doing it. And I was like, this is brilliant. And so I started talking about it at conferences. So BDD was accidental, right? I didn't mean to go out and invent a thing. I was trying to get work done. And around that time, there were 2 big projects. There was AOL, was a UK ISP, or was an American ISP in the UK. And they were just starting to push out broadband. And it was helping them automate all of that. And at the same time, Dixons, which was a UK high street retailer, they had 4 major high street brands. They were explosive growth, running on creaky old mainframes, and they needed to basically rebuild the whole company from like a technical perspective. And they'd had an incumbent. They made it a 3-year plan. It probably was a 3-year plan. They were over 2 years into the 3-year plan. They had 0 lines of code. 0. They had shelves and shelves of documents, about 10 months left, and they knew that their systems weren't going to get through Christmas, right, their peak. At which point they phoned Thoughtworks and they said, look, we're stuck. And then we sent a couple of folks in, or they sent a couple of folks in. And they went, yeah, you really are. We're not touching that. And then what happened was they said, look, we can do this. We can build, and this was like EPOS in the stores, supply chain, stock, order processing, basically building a company from public static void main, right, outwards. We can do this. It will be ugly, right? We will cut corners, right? We will hack and slash our way through this. deliberately, we're going to leave a load of markers along the way. We will only do this if you promise we then get to do it properly after Christmas, right? And they did. They were super grown up about it. It was a brilliant collaboration. And so they did. They built the Dixon's whole thing. And it really, at the time, it was one of the biggest software projects in the world, let alone Agile. Like, you had teams in UK, US, India, multiple teams, multiple offices, follow the sun development. Rebecca Parsons started as the tech lead, handed over to Dave Farley. A single build, Matt Femmel built the build, right? Single build, single source repository, bunch of teams all around the world pounding on this thing, Dave Wally, who became COO, he was the delivery lead on it, basically ran it like a military operation. It was incredible, the stuff they did. And as we came out of it, like days like this, we said, right, some really interesting things happened there. We should capture those. And so a bunch of us started writing down things like blue-green deployment came out of AOL. The single deployable artifact came out of AOL. The DB deploy, the version database changes. Sam Newman had been kind of, pioneering this stuff in Dixon's. And so we had all of the elements of a book. I mean, like, this is really cool, we'll build a book. And then one by one, we all fell off because we're rubbish. And eventually, Jez Humble and Dave Farley kind of took this book over and wrote a brilliant book. They won awards for it, they totally deserved to. And so that's where continuous delivery came from. It was just, we had to, right? That was the only way we were going to get the thing done. And I think, I've always said this, you don't learn anything on the easy gigs, right? It can be really, really tough and actually, quite exhausting. You've got to be very careful about burnout. But basically go into somewhere that's completely insane and completely impossible and fix stuff and then write it down.
So the whole CD process, whole CI/CD process, software delivery, parts of Agile and everything is a British high street retailer which was not going to be able to sell computer games for Christmas is the reason we have all of this.
A lot. But again, there's all of this, and there's a lovely phrase for it that I can't think of right now. But this idea of like concurrent discovery. When you look at what's it called, calculus. Where you've got Newton? No. Who came up with calculus originally? Yeah, so Newton. Principia Mathematica.
Yes.
And Leibniz.
Yes.
In Germany. Leibniz in Germany. Both had the same idea at the same time, slightly different vocabulary, and they both went, actually, that's really cool that we both came up with this. Their respective minions were all attacking each other for like plagiarism and theft and blah, and they were both going, no, this happens, right? So we didn't invent continuous delivery. We just we built our own version of it and wrote it down. Other people were doing this, like DevOps. The term DevOps came out of a bunch of other folks looking at exactly the same thing.
Well, you mentioned about hiring the operational folks, and often I think DevOps is it's a subject for probably another chapter. How DevOps coming together and getting the dev folks to do more operational tasks and the operational folks to do the operations in more a sort of dev kind of mode. But having software delivery, people who coders understanding the operations, and now we've got build it and run it and everything is a radical idea. But I mean, now you look at it and think there's no way you could build software without having an understanding of the operational aspect of it.
Well, and I describe it slightly differently. So I look at it in terms of constraints. So when we started doing this stuff differently, software development was the constraint. You would pour hundreds of millions of dollars into
your 2 years of design before you write any code. Yeah.
Right. So, a 2-year, 3-year release, right, of the wrong thing that we needed 2.5 years ago anyway. That was how people saw IT, because that was how a lot of IT was. So that was the constraint. So now you broaden that constraint, you elevate that constraint, and you start doing these lightweight, these iterative, adaptive, agile methods. And now suddenly it's not 2 years. It's not even 2 months. Sometimes it's 2 weeks, right? Or you can much more fine-grained delivery. That's no longer the bottleneck. Where does the bottleneck go when we can actually ship stuff? It goes downstream to release. Yeah. If you're releasing every 2 years, it doesn't matter that it takes 6 weeks and involves tears and tantrums, right? If you're trying to release every week, suddenly it's under the spotlight. So the constraint moves downstream to operations, and then the smart operations folks get together with the smart dev folks, and they go, well, what did you do? Let's do what you did. So we want to take some of your ideas, like the automation, like the working in small chunks, like the feedback stuff, but we're going to overlay it with our rigor. And I see DevOps is the rigor of operations with all of the tricks, if you like, of XP and agile kind of stuff. When it's done right, it then becomes this kind of like, we're not going to be the constraint either. Right, and that's where, and this is what Dave Farley and Jez did brilliantly, is they articulated like continuous delivery, is it becomes a pipe, it becomes just a flow. And now it becomes a flow, where does the bottleneck go? It turns out the bottleneck at that point is now upstream, right? Your business folks, your product folks can't get ideas into the pipe fast enough because they're used to working in big batches. They're used to like BRDs and PRDs and big wireframes and all this kind of stuff. You go, no, just tell us what you want. Even sketch out what you want. We'll iterate. Honestly, by the time you've told us what you want as a sketch, we've probably written half of it. Show it to you, and then and they're like, wow, can we do that? And then you start getting into like lean UX and lean startup, and so now you're moving it upstream to there. And so it's just a series of theory of constraints.
Yeah, and having visibility and being cognizant of that constraints. And funny enough, you have no idea what the next question I was going to ask was, tell me about organizational flow. And you've just, you literally went straight up the chain. I was like, excellent.
That's a nice segue. And I guess this is more like my arc in the last kind of 10, 15 years. So I'm 30 years into this, 30 something years into this. And it kind of splits fairly neatly into decades. So first decade developer, and then just various adjectives in front of developer, becoming more senior and doing stuff, right? Then joined Thoughtworks 2002, and then it's much more working with a variety of organizations, helping them get stuff done. And a lot of their getting stuff done is sitting there coding or pairing with people coding shoulder to shoulder.
So in a way, it's taking a developer-focused task and scaling it out to an organization so they can be more effective individual developers in a pipeline organization.
Right, exactly. And then so around the sort of mid-2000s, I've always been a bit of a, like, I love the glue, right? Much more than particularly, I've been in like trading environments, telcos, retail. I don't get like particularly excited about a vertical, about a particular domain. Industry, yeah. What I want to do is glue stuff together, right? So I'm a build nerd, a release engineering nerd. I love all that stuff. So at one point with AOL, we had a build team of 8 people. And the 8 people were like, Chris Reed, Jez Humble, Julian Simpson, just insane. Dante Briones, just some brilliant people.
The Avengers of build pro.
It really was. And I still describe it as 8 too many people for a build team, right? Your build team should be no people. Yeah. But out of that came, as I say, a lot of the patterns that ended up in the book, the blue-green deployments came out of that single deployable artifact, the paper, the build production line paper. So the kind of the release engineering and the build engineering piece. And so I was kind of starting to pan back a bit, and it wasn't like writing software is okay, but written software is useless unless it's live, right? Live software is useless unless it's solving a business problem. Live software that's solving a business problem is useless unless you get the feedback to figure out, and so on, right? So I started panning back to how do teams work, how do teams of teams work. And what I wanted to, my mission, if I have a mission, I'm trying to figure out how to help organizations work effectively in a way that I can step away and it carries on being true. And I'll tell you why that is. When I was at Thoughtworks, and it happened again and again, and it wasn't their fault, it wasn't Thoughtworks' fault, it wasn't anyone's fault, but this kept happening, is you'd go in, you'd write great software because they had very great, brilliant engineers, and they would typically work with a team. And what you saw, and James Lewis is also at this conference. I'm so fond of James. James was one of my very first kind of folks that I met him in Thoughtworks and thought, man, you're going to be special, right? There's something about you. And I got to work in a team with James in about 2007, and the energy in the team changed, right? People were bouncing into work. They were having fun. Yeah, and you're like, we did this. We caused these people to have fun. Isn't that cool? And then so you'd step away and we'd go off to the next thing. I remember I went back to a particular bank about a year and a half later, same team, and everyone was just checked out.
Yeah. Half of them was gone. Yeah.
Half of them had quit because it's never going to be like that again. The ones who were there were just like dead behind the eyes, and I broke my heart. I was like, right, how do we do this so that when we go in there and make change, it's sustainable, it's sticky, it's systemic, right? And that's still my kind of kick now, about 15 years later, is this is what I do. I go into organizations, I work with organizations, I'm available. Hit me up on LinkedIn, I'd love to hear from you. I tend to go at a fairly senior level. I get hit up by COOs and CIOs and folks, or CXO -1 or that kind of level, and I don't know why, but they come across my talks, they come across work, or they hear about me or whatever, and they're saying like, I've got this organisation and it's a bit broken, and can you help? And my default position is always, I have no idea. Right? I have no idea. Why don't I come in and meet you and meet some people and do some listening and see what happens? But that is, for me, that's the big win, right? How to write, being able to write software well, being able to ship it, deliver it, get it out into the world, get feedback on it. That is a necessary but not sufficient part of the puzzle.
So is there something in your engagements that comes top of mind, that sort of circle of a business idea into all the technical implementation, gets out to prod, is used by users, and that sort of missing gap?
Well, and the feedback.
The feedback circle, is there something you can distill in what is missing with that, or you still figuring that out?
That's easy. I can tell you that right now. It's called product management. The bit that's missing is product management, and I've been very lucky. I've gotten to work with some brilliant product folks over the years. I mean, at Thoughtworks, I work with Jeff Patton, the guy that came up with story mapping, user story mapping, utterly brilliant. Mark McNeil, fantastic UX designer, product manager, just wonderful people. Latterly, Jeff Gotthealth, I've been very lucky to work with Jeff Gotthealth, who literally wrote the book on Lean UX. And the way I describe it is baking the right cake and baking the cake right. I'm really good at baking the cake right. I do not have a commercial bone in my body. I could not tell you. I can talk a good game. I can talk a good game about theory of jobs to be done, about Clay Christensen, about, I'm fascinated by this stuff, but, I don't do it. And when I see it done well, I'm like, you need that. So I tend to now buddy up with, so there's like product management, which is that squaring the circle piece that you're talking about, and product development, which is how do you make the thing? So what I'm really good, I like to think I'm good at, what I specialize in at least, is making the thing. Whether it's the right thing, right, what the thing should be, that's a whole product strategy piece, and I'll find someone who's really good at understanding, user research, at looking at the market, that's figuring out what's going on there, and that feedback, that full circle, that works as a really good complementary.
Is that still some of the failure of, big IT organizations, even small IT organizations, having the project thinking rather than the product thinking? And there's a book out there, thinking in products instead of projects. When you have a project, we're going to do this kind of thing, and it finishes. While the sort of product is you are running something that runs forever or for a period of time, and then that implicitly requires that feedback loop, because you need to continually evolve your product rather than just you've got a 2-year project and then that's finished.
So I hear you. No, so all that. So yes, and what you're describing is still baking the cake right. So the project product thing is, I look at it as a funding and a governance piece, right? So this is I'm going to do the whole of governance. I'm going to tell you the whole of governance, right, is 2 questions. What are you spending my money on? How's it going? That's the whole of governance, right? What are you spending my money on is investment. How's it going is risk. The problem is, in any non-trivial organization, I've got no idea what I'm spending my money on, and I've got no idea how it's going. Right? And so this is where all the governance theatre comes in, and the steering groups and the RAGs and all of that stuff is, we can't answer these questions. And so rather than let's jump through hoops trying to answer these questions, this is where I want to flip the whole thing around and say, well, let's change the organization such that these questions become easy to answer. And that's when you shift from cost accounting to throughput accounting, or when you shift from activity-based metrics to flow-based metrics. Is all of that makes these questions easy, right? I can see where, my Wardley map of which things are Genesis versus which things are commodity, right? All of that is, where am I spending my money? How's it going? Right? It's all the same stuff. So the project product thing is, you can think of a project and a bigger scale, a program of work, as a way of batching money. That's the whole thing. Yeah. And the reason you batch money is to manage risk. right? At worst, it will spend, I'll lose that money. If I'm going to run a £10 million program, the most I'm going to lose is 10 million, which is a complete nonsense, because the most you're going to lose is all the opportunity cost of all the other things you could have done. And there's probably hundreds of millions you're leaving on the table because you're looking at the cost and not the opportunity, right? So we get the economics wrong in the first place. But project versus product really is an operational thing about how you fund work. So product funding is, I'm going to basically treat you like a venture investment, like an angel investment. I'm going to keep on funding you as long as I'm seeing interesting stuff. As soon as I stop seeing interesting stuff, I turn the tap off, right? That's pretty much the whole difference. It means that I have much less what's called VAR, value at risk, right? If you're continually delivering stuff and that stuff is starting to make money, I've got much less value at risk. If I'm just pouring money in and I'm not getting anything out yet because there's a big batch release coming up, that's a ton of value at risk. So it's a very different governance model. But it's still, none of this is still, am I building the right cake? Am I baking the right cake? I will have trailing indicators of whether I'm baking the right cake, but what if this thing's making money? I'm not going to know that a different thing could be making 6 times that money because I'm not thinking in hypotheses, right? I'm still thinking of like, well, it's paying its own way, it's probably fine, right? So we don't even have the thinking around that. So product project is a funding governance question. There's still, and I'm just as guilty as anyone, in probably at this conference certainly, that we are the baking the cake right people. We're really, really good at this. Then what my appeal to folks watching this now as well, hang out with product people, go to product conferences, go to places that are outside of how the machine works, and start talking to people about what the machine's even there for. I think when we do that, when you bring those things together, it's really, really powerful. I've seen brilliant product people who cannot execute, right? They've got all the ideas and they're the right ideas and nothing happens. I've seen brilliant delivery people, like Peter Drucker's lovely quote, there's nothing more wasteful than very efficiently doing exactly the wrong thing, right? Yeah. And we do that again and again, so yeah.
So your 15-year challenge is still not finished, it's still working all this out?
No, it's still exciting, I've got some...
But I've spoken to a few other speakers who said, when are you writing a book then?
So let me tell you about my undiagnosed ADHD. Let me tell you about my inability to finish anything.
You've bought the domain name.
Well, no, I have. I'm 12 years into writing a book that has been called Software Faster, which is patterns of effective delivery. I started collating these patterns, curating these patterns about 2011, 2012. There were 10 of them. A couple of years later, I was teaching the classes, and it was iterative and generative and blah, and like Kevlin Henney talks about stone soup, and you have this kind of thing where suddenly all these ideas are there. And now there were like 40-something of these patterns, and I'm like, well, 10 patterns is a class, 40 patterns is a book. So I'm going to write down these 40 patterns. And so I wrote, on LeanPub, I wrote 40 chapter titles with little 1-paragraph things. And I thought, that's easy, I'll just go and fill in 40 chapters and I'm done. So that's been languishing for a while. So then I got working with a brilliant co-author, and she said, right, make it manageable. Because these 40 patterns are about 8 sort of chunks.
So it's like software delivery. Make it manageable in smaller chunks.
Make it manageable. And I'm like, oh yeah. So we took out just the team patterns. So these are, I've got to actually go to Chicago talk from a few years ago, patterns of effective teams. And it's those and a couple of others. Let's just take the team patterns. They're well formed, they're well articulated, we can get that, that's tractable, right? Let's get those done. So we are dangerously close to shipping that now. There's like probably 1 or 2 chapters left to write of that, and we want to get some pictures, some illustrations in there, and then we're going to ship it. So it may even be this year, certainly early next year. So I'm very excited about that. That'll be the first actual book. I've written chapters of things and like a ton of forewords and stuff. I've never actually published a book.
Well, many people are keen and waiting for that as well. So is there anything we haven't spoken about today that you think is top of mind?
Good heavens. Almost certainly. Almost certainly. I guess it's worth mentioning, the thing I'm talking about here at this conference it's a talk I've given a couple of times now. It's called The Best Programmer I Know. And it started as a stream of consciousness thing, like on Twitter, back when it was Twitter, before the bin fire. And before I was going to say before the Nazis, but that's not true, before the much more prevalent Nazis. And I'll tell you how it started. It started with someone saying, you need a CS degree to be a programmer. And I just went, no, you don't. No, you don't. And I said, like, the best programmer I know never went to university. It was actually a lie. He went for 6 weeks, decided it wasn't for him, and quit. The other best programmer I know has got a first-class honours degree from Imperial College. Right?
Yeah, so both,
you know, neither necessary nor sufficient. And then that got into, well, what do you mean by best programmer? So I just went, blur. And there's this big stream of consciousness Twitter thread. I should do something with that 4 years ago. Yeah. Right.
No, it is a good
Finally got it into a talk. And so I've been talking about this, and I took it out the first time was earlier this year, and I was so nervous about this talk. Because A, it's very personal, and B, like, I didn't know, is this going to be like useful for people, or is this just a massive self-indulgent like? And anyway, so I gave this talk, and the feedback I got was just lovely, like really lovely. So I'm talking about that, and I think it's important that we remember that programming is, you hear this word, and I'm glad this word's becoming much more prevalent. I'm worried it's going to become a cliche, or already has jumped the shark, is this idea of socio-technical systems. Yeah. Programming is a socio-technical activity. It involves technology, it involves human beings. And unless we are very, very cognizant of the human beingness in it as much as we are with the technology bit in it, we're going to just keep getting it wrong.
Yeah. Well, that's from your stories earlier of doing the circle of the whole product design phase, feeding them back that in. I mean, that's communication between people, and sure, code is written and delivered, but articulating a business need to a business problem to doing all of that is people.
Basically the same thing. If you think of your delivery world as a product, the people involved in that delivery are basically the customers of that product, the users of that product. We want to, what do we want to do with that product? We want to affect behavior change. We want to make people have more fun. Excellent.
Well, it's been fascinating to chat to you. I think we've got a book to look forward to, more talks to come. Dan North, that's awesome to talk to you. Thanks so much for joining us here today for another session of GOTO Unscripted. Until next time, thank you very much.
Thank you.